By the year 2000, a manned space vehicle unlike any other will orbit the Earth. It will be called Space Station Freedom. Onboard Space Station Freedom will be manufacturing areas for new materials, metals, and medicines. This weightless environment will host countless experiments planned by many in the world community. Someday, it may serve as a rest area for a manned trip to Mars. The inhabitants of Space Station Freedom, scientists, engineers, astronomers, and others, will live, work, and play in an environment very different from that on Earth. However, the electrical energy needs for these people will be similar to those needs in any modern community. Sufficient power must be provided for the day-to-day operations in the space factories, as well as in the private accommodations for the astronauts. Electrical power on Space Station Freedom is not a luxury, it's a vital necessity. On Earth, losing electrical power is a major inconvenience, but for the most part, survivable. However, if the electricity was lost on Space Station Freedom, more than just the lights will go out. The Rocketdyne division of Rockwell International is under contract to the NASA Lewis Research Center in Cleveland, Ohio, to make sure no lights ever go out on Space Station Freedom. This contract with NASA Lewis for the electric power system is called Work Package 4. To develop and test this power system, the engineers at Rocketdyne have built a space station power laboratory, commonly referred to as SPEL, at their DeSoto complex in Canoga Park, California. This lab will accurately simulate the electric power structure on Space Station Freedom. The manager of SPEL is Dan Rod.
The Space Station power system is the most complex and the largest system of its kind ever built. Rocketdyne has built the SPEL facility in order to test and develop the power system. This environment is extremely complex. It consists of computers, software, and electrical power components, which are extremely hazardous. In order to perform tests of the power system reliably, consistently, and accurately, we have to have the means to run the test, produce results, and get test reports which will be reliable and accurate. In order to do that, we're going to carry an idea that was developed originally on the Space Shuttle program, but it's going to be further developed on the space station, which is to automate the test. Instead of having operators key in every command, we're going to have software and computers which run the entire test end-to-end and produce reports, and will be extremely reliable and accurate.
This call for an automatic testing mechanism was answered by a team of highly skilled computer specialists at Rocketdyne. After careful study, the test equipment software engineers designed and coded a computer program to answer the needs of the test engineers. The objective of this software program is to provide the engineers with a way of creating computerized tests of the space power test bed without the need for a thorough knowledge of computer programming. At the same time, this test environment needs to have the flexibility to allow the engineers the opportunity to test any piece of equipment in the test bed and accurately trace its response. The software being developed has been named the Automated Control Environment. It has quickly gained acceptance as the most cost-effective and efficient way to test the space station power bus. The Automated Control Environment, or ACE as it's now known, answers all of the needs of the test engineers who are designing and testing the space power electrical system. A lot of thought went into the design of the ACE. The test equipment software engineers realized that the creation of a new test language custom-tailored for the Space Power Electrical Lab could be very costly to produce and maintain, so a different approach was necessary. Many existing software products were investigated to see if any of them could be modified to meet the needs of the ACE, and many of them did. The first requirement for the ACE was that it should be user-friendly. That almost always means that a program should be menu-driven. Menus can be very time-consuming to create, but not if you use a menu management system that has already been designed. The test equipment software engineers decided this was part of the answer. But the real challenge was to come up with a test language that was easy to understand for the SPEL test engineers, while at the same time easily interpreted by the computers that would eventually perform the tests. It sounded like a tall order, but the software engineers thought about an innovative solution. Why not create a test language which contained test instructions in a programming language called Ada? The answer to that question was obvious. The test engineers couldn't be expected to learn Ada programming in order to run tests in the spell. But what if a straightforward test language was developed that suited the needs of the test engineers, while at the same time met the specifications of the Ada language? It was a great idea, but one bridge had to be gapped. How could a straightforward test language be converted into Ada code that a computer would understand? The test equipment software engineers found an answer to that problem. They took an existing source file editor and modified it. This editor was set up to understand the test commands of the test engineers. Not only did it understand the commands, it was designed to ask them appropriate questions and also to help them fill in the blanks as they went along. Then, using routines developed by the software engineers, this test language was converted to Ada executable instructions for the controlling computer. It was the perfect solution. Using this new innovative software program, the test engineer will be able to write and store a list of test instructions in a test file before a test is performed in the lab. The computer will then control the test equipment as specified by the test file. This enables the test engineer to program complicated tests and duplicate any test exactly. The ACE will also allow the engineers to deliberately create false conditions so that the main computer's response can be checked to assure that the problem is handled quickly and without further incident. The automated control environment represents several elements of good software engineering. It makes use of existing software products. The ACE is very user-friendly. It is menu-driven, so that new users will require minimum time to learn how to use it. And because the ACE is written in Ada, and the development process followed the methods of object-oriented design, it will be easily modified and maintained as the spell tests grow in complexity. This is just one way that Rocketdyne is working together with the NASA Lewis Research Center to create innovative solutions. Together, we will ensure that Space Station Freedom will constantly pierce the darkness of space with light.